So once you, I'm Gordy Stein. So once you develop the code, you're going to want to test it somewhere. So you're going to want to test it either on a physical device, the phone, your phone, or an Android virtual device. The best way, well, the physical phone has access to all the sensors. You can mess with the accelerometer, you can walk around and test it, see if your program works for that. And the Android virtual device, not so much. You can't walk around with a computer with the accelerometer in it. It's a virtual phone. So then the physical device, there's a couple things you have to set up to actually get it to work. First, you have to declare your application debuggable, and that's on the phone. And then on the Android manifest, go into applications on Eclipse, click debuggable, and then you're going to just connect it with USB. If you're using Windows or Mac OS, the drivers are already on there. And this is the best choice for testing. You can test every possible scenario. And the developer's website says that before you even publish the application, you need to test it on an actual phone. Your other option for simulation is the Android virtual device. And this is kind of like a virtual phone on your computer. Same functionality, but there's some options that you do have to choose. This is to choose your operating system. Yet again, so this is building a phone on your computer, and then what you're working with, the minimal OS for the phone that you're working with, OS version, you have to choose. So Android 2.1 or what you're making. And then the other option is you have to select all the hardware you want that phone to be built with on your computer. So yeah, if you want the accelerometer, if you want the GPS support, you have to explicitly state that and choose those. And then once you finish this process, it'll create a phone on your computer, and you can run that code and see how it works. And then I think I'm going to hand it off to Andrew.
Excuse me. I'm Andrew Kling. After you've gone and downloaded your software, developed your code, and debugged it, the last thing you want to do is distribute it and share it to a user base. So a few preparation steps you need to do is first digitally sign your app. This identifies a unique author to the app, and also the operating system looks for this unique key every time it goes to install an application. So if it's not digitally signed, your application won't install. Next, you want to version your application. This is an ideal strategy for updating and maintaining your software. Design an icon. Google set a strict set of requirements for designing an icon for different density screens and resolutions, and these guidelines need to be followed. I've shown our team's icon, the iDocent, over on the right there. Next, determine an app category. Is it going to be a game? Is it going to be for health? Is it news, etc.? And then some optional things to consider are an end-user license agreement. All of us have seen this when we're installing software on our computers and we almost hit agree in order to use the application. This is something we might want to consider. Also, licensing. An example of this is the TomTom GPS software for smartphones. They offer a yearly subscription to live traffic updates, and they have a license behind this, and you get it for 1 year, and you get to see your live traffic, and it determines new routes based on this. So these are some things to consider in preparation for before you actually get your app out there. So marketing. So the last thing you do before when your code is all finished is export your file to a .apk. So you have a few options with this APK. The most popular is to publish to the Android market. Now, in order to do this, you need to register a Google account. If you already have a Google account, you can tie in a market account with it. There's a one-time $25 registration fee. And after this, you're free to upload your applications and update as you see fit. Within the Android market, users can see, download, and rate your applications. Now, rating is obviously important so you can receive feedback and offer new updates and features as users are requesting them. There's some other options you can go through to distribute your APK. You can email it to a friend, post it on a personal website. Amazon has recently come out with their own app store. You can choose to go this route. or there's a few other ones I've listed here where you can publish your app as well. So some interesting facts I found when researching the Android market. There's over 150,000 live applications in the market, and over double that amount have registered for the certificate with the unique key that I mentioned first off. So there's a ton of applications out there, and people are using different methods to distribute them. So over half of those applications are free. I've done a little comparison to Apple's App Store on here. Only a quarter of theirs are free. The average price of one of their paid apps is around $327. Same price for Apple. About 3,000 applications are developed every month. Apple is much higher than that. They've also been their app store has also been more developed and has been out longer. So the allowable price range for an app in the market is 99 cents to $200. And of this price, you get to keep 70%. Now what's cool is Google takes this other 30%. Instead of keeping it like Apple does, they distribute it to your wireless carrier such as AT&T or Verizon. I thought this was very neat. So we'll go ahead and move on. Now, everything you've learned today, I've showed you some of the software packages you need to download and start making an application, some of the basics behind making the Hello World, how to test and debug, whether it be on a physical phone or a virtual AVD, and how to distribute and share your app. And we've covered these with the 4 Ds. Are there any questions?
Any questions from the class?
Rachel?
What application did you find? Which one costs $200?
No.
They
I
used
know
to-
there's some surveillance.
They used to sell Wolfram Alpha for $200 when it first came out on
I
Android
can't, I'm
phones.
sorry, didn't hear the answer.
He said Wolfram Alpha, it's a mathematic application. He said it was $200 when it first came out.
You said it had to be debuggable before it could go on the Android marketplace. Is there how many phones has to be tested on, or is it just one phone that has to be tested on?
The site said it has to be tested on at least one phone.
On one.
I mean, it's not going to function any differently than the AVD, but just to make sure, you know.
So they give 30% to the wireless carrier. Why do they do that?
Oh, Google's never been one to take your money, so they've always offered free stuff, so they were rewarding the carriers for carrying their phones. So,
All right, I got a couple of questions, pretty pragmatic questions. Those are good, those are all good questions, but how do you get, this is very pragmatic, how do you get that 70%? Do they send you a check? I mean,
well, I'm sure, I actually don't know, but I'm guessing it goes through their Google checkout, because that's how you pay for your registration fee. It's kind of like PayPal, but Google has their own version called Google Checkout,
Okay.
and that's how they deal with all their money
so they just
processing.
deposit that money
So I'm
and
sure it
you
comes
can
right into
transfer
your
it to
account
them.
like that.
All right, and I often get visits from freshmen, usually with their parents when they come to visit the college. And one of the questions that I'm getting asked over and over again is the kid wants to go get an engineering degree, and I say, well, what do you want to do long term? I want to develop phone apps, and I'm hearing that more and more. I don't know if that's a viable career option really, because it's kind of hit and miss, and you might hit on a big one and make a lot of money, and you might work for years and years and not make anything. But the question is, what skill set should I recommend to a young, like a freshman, who's coming in as a computer engineer, who wants to develop phone apps?
I think most importantly, he has to be a user of a phone, and I mean, I've been using the iPhone since it came out, and I've seen all the top apps.
Well, but I mean, as a
through
developer,
everything.
what programming languages would you recommend? What do you think is going to be the trend in the future? Obviously, what the computer science department is offering, Python, isn't going to be much use
No, not
here
at
at all. Which is a good
And
argument.
with
against
computer
it.
engineering, we only don't take just Python. We also take C++,
Right.
and other object-oriented.
But C++ isn't really.
But the thing is also that C++ is very syntax specific, and if you can program C++, you can program anything. Java is very simple.
Yeah.
It's-
So basically, Java
transitioning-
though is what you need to be the expert in.
Yeah.
The more experience you have in Java programming, the better off you be.
It is, but they also inherit a lot of the same ideas. So, and if you're a computer science major here, you're going to get exposed to a lot of that stuff, and you're going to be able to transition it to Java and use it, especially like on these applications.
And we learned, in a couple classes, we learned C#, and C# is really closely related to Java. So.
Okay, good. All right, thanks a lot.